Hey everyone, today we're going to go ahead and do a few examples on how to solve for multiplication and division inequalities. So if you recall, an inequality is an expression where we use the symbols less than, greater than, less than or equal to, or greater than or equal to. So let's take a look at one example. This is example 1, and this is going to be a multiplication inequality. So let's say, for example, I have 5 times x is greater than or equal to, let's try 45. You know what? Let's bring it up a notch. Negative 45. Okay, so here I have this. Think very carefully about the steps. Write the steps down with me. Step 1, I want to identify the variable. What do I need to isolate? Because the goal of an equation or an inequality is always to isolate the variable, because you want to know what that x is. You want to know what that is so that you can isolate it. I'm going to write the steps here on the side. So step 1, isolate the variable. Well, now you need to, what are we going to use to isolate the variable? Using inverse operations. What does the word inverse mean? The word inverse is another word for opposite. So, if I'm multiplying 5 times x, what is the opposite of multiplication? Division. That means that I'm going to divide by whatever is accompanying the variable. So the opposite of multiplication is division. And vice versa, the opposite of division is multiplication. So now what I'm going to do is I'm going to divide both sides by 5. Well, that would be the second step then. Do it to both sides. Do it to both sides, right? So I'm dividing by 5. This means that 5x divided by 5 will leave me here with a 1. And then over here I also divide by 5. So now here I'm left with 1 times x, which is greater than or equal to, what's negative 45 divided by 5? You're dividing a negative by a positive. In this case, you would need to use your tic-tac-toe for us to remember what is a negative divided by a positive. Remember, positives go all the way down, negatives go over here, and then we have here that a negative divided by a positive is a negative. Therefore, negative 45 divided by 5, well, 5 times 9 is 45, but then in this case, it's going to be negative 9. So I did step 1, isolate the variable using inverse operations, check, because I did division. Step 2, do it to both sides, check, I also did it over here. Step 3 now. Well, now that I have that, what is 1 times x? Well, that's just x. Every time that you multiply by 1, you get back the same number. Now we have used the, what is that? When you multiply by 1, when you add by 0. That's called the identity property. Use the identity property to leave the variable alone, which we just did. It's already by itself. Okay. And then I just go ahead and bring my symbol down. Don't forget to bring your symbol down, and you have negative 9. So therefore, this means that x has to be greater than or equal to negative 9 in order for the inequality to remain true. Okay, so what does that mean? That means that, and obviously the very last step is to now check your solution. So now I'm going to go ahead and check. What this means now is that I can put negative 9 or anything greater than negative 9. So let's go ahead and let's try negative 9, right? So I'm going to put 5 times, instead of x, what do we put? Let's try negative 9. Has to be greater than or equal to negative 45. And this will give it back true. Well, 5 times negative 9 is positive times negative is a negative. This is negative 45 is greater than or equal to negative 45. So this is true because it's equal to. Let's try negative 10. 5 times negative 10 greater than or equal to negative 45. Is negative 10 greater than negative 9? It's not. It's actually less than negative 9, because when you're in the negative side, it's like opposite world. It's like the upside down, right? The greater of a negative number that you are, the more negative that you are, the less value that you have. So this is going to be negative 50 is greater than or equal to negative 45. This is false. Negative 50 is not greater than negative 45. And how do we know what number to substitute in there then? Well, we know that it has to be greater than or equal to negative 9. In other words, the solution set would be negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, and so on, etc., all the way till you get to the greatest value. Okay? And if you put anything else that is not greater than negative 9, then the inequality will always be false. So my very last step was to check, which we just did. This is a multiplication equation for you. And it's awesome because in any inequality, any equation that you have, the steps remain the same. These steps will remain the same. Now let's go ahead and take a look at a division inequality. Let's say that this time, for example, instead of having that, now I have, let's try, x over 4 is greater than or equal to negative 3. Now on your quizzes or on the application that you might be using, sometimes instead of showing that, this is just to show you, the division is sometimes shown like this, x over 4 greater than or equal to negative 3. So instead of it having this part that you're used to, this is going to write it down in this format, but it means the exact same thing. It's just slanted differently for formatting. Okay, so this is the same thing as this inequality. X dash 4 is the same thing as me just doing x divided by 4, just for reference. Okay, so here I have this. Remember, step 1, identify the variable. Let's identify the variable, it's x, and isolate it using inverse operations. If I'm dividing by 4, what is the inverse of division? The inverse of division is multiplication. Therefore, I am going to, that was step 1. Therefore, I'm going to multiply by whatever number is located with the variable. So let me just rewrite this real quick. I have x over 4. I'm going to rewrite it for space. And I'm going to multiply by 4. Step 2, don't forget to do it to both sides. Do not forget to do it to the both sides. I'm also going to multiply by 4 over here. Let's take a look at this left side that we have here and why we are able to isolate the variable. So if you really think about this, you have 4 times x over 4. So it's like if you have a whole number multiplied by a fraction. Whenever you have a whole number times a fraction, we always say this: draw an invisible 1, draw an invisible 1 underneath so you can multiply across, right? And now it's easier for you to just say, well, 4 times x over 1 times 4. Well, what's 4 times x? 4x. Just put them together. What's 1 times 4? 4. Greater than or equal to? What's negative 3 times 4? Tic-tac-toe. Let's look at our tic-tac-toe. A negative times a positive is a negative. We already had it over here. So this is going to be negative 12. But then this left side, you see how this lends us to come down to 1 again. How? You're dividing 4 divided by 4. 4 divided by 4 is just 1. Therefore, now you're left with 1 times x is greater than or equal to negative 12. Look at this identity property. Again, every time you multiply by 1, you end up with the same exact number that you were multiplying or dividing by. So we're going to use the identity property to just give me back x is greater than or equal to negative 12. And lastly, we're going to check our solutions. So let's see what number can you substitute for x in order for the inequality to remain true. Well, it has to be greater than or equal to negative 12. Let's try negative 12 since that's the number that's given to me. I'm going to check over here. I'm going to rewrite my inequality. And instead of putting in x, we're going to substitute negative 12. Let's try it. Negative 12 over 4 is greater than or equal to negative 3. Remember, this is the same thing as me just saying negative 12 divided by 4, which is negative 3, greater than or equal to negative 3. Is negative 3 greater than or equal to negative 3? Yes. Therefore, that remains true. What other number can I put in there that will make it true? Well, remember, anything that is greater than or equal to negative 12 will make it true. We already checked negative 12. What's the next number that's greater than negative 12? Is it negative 13? It's not. That's less than negative 12. Remember, the more negative that you are, the less of a number that you are, the more that you lose your value. So let's try negative 11. Let's try negative 11. And some of you might have noticed you're going to get back a decimal, right? And I'm going to kind of cheat a little bit here. So I'm going to put negative 11 over 4 has to be greater than or equal to negative 3. Remember that this just means negative 11 divided by 4. Let's see what that equals to. This is actually 2.75, negative 2.75 greater than or equal to negative 3. Is negative 2.75 greater than or equal to negative 3? Yes, it is. In the negative world, it is. Because it is better for you to owe someone $2.75 than for you to have to owe someone $3 whole dollars. So yeah, this actually is also true. Okay, so if we get lost, just go ahead and make sure that we're following our steps, our solutions. Make sure that you are using your tic-tac-toe to help you remember the rules of multiplication and division. Okay, thank you for watching.